everyone, welcome back to my channel. I am Venkatnarayan TL, a second year student at Sri Venkateswara College of Engineering, Bangalore. Today's title is Mathematics and topic chi-square distribution as a test of goodness of fit. So let's move on to table of contents. We are going to cover what is chi-square test, chi-square test formula, fundamentals of hypothesis testing, types of chi-square tests, and chi-square test examples. So, what is chi-square test? The chi-square test is a statistical procedure for determining difference between observed and expected data. This test can also be used to decide whether it correlates to our data's categorical variables. It helps to determine whether a difference between two categorical variables is due to chance or a relationship between them. So a chi-square test or comparable non-parametric test is required to test a hypothesis regarding the distribution of categorical variable. Categorical variable, which indicates categories such as animals or countries, can be normal or ordinal. They cannot have normal distribution since they have few particular values. And so this is the chi-square formula, that is xc squared equals to sigma oi minus ei squared by ei. C is nothing but degrees of freedom, O is nothing but observed value, and E is expected value. So the degree of freedom in statistical calculation represent the number of variables that can vary. The degree of freedom can be calculated to ensure that chi-square tests are statistically valid. So these tests are frequently used to compare observed data with the data expected to be obtained if a particular hypothesis were true. And the observed values are those you gather yourself, and the expected values are the anticipated frequencies based on the null hypothesis. So what are the fundamentals of hypothesis testing? Hypothesis testing is a technique for interpreting or drawing inferences about a population based on sample data. So it aids in determining which sample data best supports mutually exclusive population claims. So null hypothesis. The null hypothesis is nothing but the assumption that the event will not occur. A null hypothesis has no bearing on the study's outcome unless it is rejected. So H0 is nothing but a symbol for it, and it's pronounced as H0. So alternative hypothesis, H1 or HA. The alternative hypothesis is a logical opposite of the null hypothesis, and the acceptance of alternative hypothesis follows the rejection of null hypothesis. H1 is the symbol for alternative hypothesis. So the types of chi-square test, there are two types. One is nothing but independence and other is goodness of it. Independence. The chi-square test of independence is a derivable, also known as inferential statistical test, which examines whether the two set of values are likely to be related with each other or not. The test is used when we have count of values for two nominal or categorical variables and is considered as non-parametric test. A relatively large sample size and independence of observations are the required criteria for conducting this test. So example, in a movie theater, suppose we made a list of movie genres. Let us consider this as first variable. The second variable is whether or not the people who come to watch those genres of movie have bought snacks at that theater. And here the null hypothesis is that the genre of the film and whether people have bought snacks or not are unrelatable. If this is true, the movie genres doesn't impact snack sales. So goodness of fit. In statistical hypothesis testing, the chi-square goodness of fit determines whether a variable is likely to come for a given distribution or not. We must have a set of data values, and the idea of distribution of this data, we can use this test when we have value count for categorical variables, and this test demonstrates a way of deciding if the data value have a good enough fit for our idea or if it is representative sample data for the entire population. So example, suppose we have bags of balls with 5 different colors in each bag. The given condition is that the bag should contain an equal number of balls of each color. The idea we would like to test here is that proportion of 5 colors of the ball should be exact and equal. So some of the chi-square examples are chi-square test for independence. A researcher wants to determine if there is an association between a gender, male and female, and preferences for new product. So the test can assess whether preferences are independent of gender and goodness of it. Example is, let's consider dice manufacturer wants six-sided face is fair, and they roll the dice 60 times and expect each face to appear at least 10 times. The test checks if the observed frequency matches the expected frequency. And test for homogeneity. So a fast food chain wants to see if your preferences for a particular menu item is consistent across different cities. The test can compare the distribution of preferences in multiple cities to see if they are homogeneous. And test for contingency table. A study investigates whether smoking status is related to the presence of lung disease. And proportion example is, a political analyst want to see if the voter preferences candidate A or candidate B across different age groups. So basic step for calculation of this chi-square is, so H0, that is nothing but variables are independent. H1 is nothing but variables are related. So we need to prepare a table, organize the observed data in contingency table, and compute row and column or totals. So add up the values of each row, column and overall total. Then we use this formula to compute and calculate the value. Then sum all the values, add up all the values results to find the chi-square and determine the degree of freedom. So degree of freedom formula is nothing but r minus 1 and column minus 1, that is row minus 1 and column minus 1, and then we compare the critical value. So here I would like to conclude my video. Thank you for watching my video and have a nice day. Goodbye.